Alright, welcome back. So this might be a bit short because I need to go get dinner, but we're just gonna do some practice using the practice sheet, the first practice sheet I gave to everyone a little bit ago. So this is gonna go over just a nice walkthrough of how to do a problem in two different ways, but also one last trick that I didn't say in other videos, but you've learned in class. So to start off, I'm gonna do number 6, which is log base 6 of x plus log base 6 of x plus 4 equals log base 6 of 21. As I said before, the first thing we want to do is max 1 log on either side. That is the first thing we want to do. And I see on the left side I have 2 logs. The right side I only have 1 log, and that's fine. We'll touch on that in a minute. But these 2 logs, I could just combine them. If there was a number in front, a coefficient in front, that's being multiplied to the log, I cannot combine it because our formula before is this sum property of logarithms is I can only add just logs, same base, nothing in front. This I would need to bring it inside. But since there's no coefficient in front, no number multiplying them, I can use the sum property. Where if I have the same base log, I can multiply the insides. So I have log base 6 of x times x plus 4 equals log base 6 of 21. Here we just multiply it inside, clean it up, log base 6 of x squared plus 4x equals log base 6 of 21. At this point, this is something I said in class, but there's a property, like logs are functions, and functions mean that if I give the same input, I will get the same output. Like if f of 4 equals 21, every time I put in 4, it'll always be 21. It's not all of a sudden it's gonna change and give me 20 or like negative 10 one time. The functions will never change. It's always, if I give the same exact input, I'll always get the same exact output. So if that is the case, if I give the same log base, like they're both log base 6, if I give the same insides, they must be the same. Like this must equal 21 for it to be the same. And it happens because this function is also 1-to-1, which we didn't really cover. But it's like every output only has one input. So it can't really repeat. Like it's not like, oh, log base 21 and log base 12 are equal. That's not the case, which we didn't touch on that much, but it's like this works for logs, so we just trust it. So I could split it up as x squared plus 4x equals 21. And solve this using algebra, where if I have a square or quadratic, I want to bring it over, set it equal to 0. And you can solve it, factor it out, plus 7, x minus 3, to get x equals negative 7 and 3. Finishing these out, we're not done yet. I have to check my answers. Because log b of c can never be negative. Like we learned this before with like x equals y. The domain can never be negative. X always has to be greater than 0. It cannot even be 0. It has to be greater than 0. Actually, no. Yes, yeah, I'm right. It can't be 0. It has to be greater than 0. So therefore, I have to check, I plug it back in. If I plug in negative 7 into here, I have log, my original, the first line. I don't care about this line. I don't care about the second line. I care about the first line. If we do log of negative 7, I see immediately the red flag. This does not work, so negative 7 does not work. If I plug in 3, I do log base 6 of 3 plus log base 6 of 3 plus 4. And it does work. There's no negatives, it works. So x equals 3. And we're happy with it. Now the other way that I taught us originally is we use properties. Where if I have log base 6 of x squared minus plus 4x, it equals this. That's why I said like you want to get just one log at either side, I could move this log to the other side. So instead of doing equals, it minus log 6 base 21, like base 6 of 21 on both sides, and it equals 0. You then combine it to get log base 6 of x squared plus 4x over 21 equals 0. We do our B, C, and A. This is a key thing. I see a lot of silly mistakes with this. It was our first thing, and I realized in class, like, especially with math, we learn so much stuff that oftentimes the first thing that we learn, we kind of becomes muddled. But please make sure you practice this and practice it accurately, where you label your base, your argument, and your result, and it becomes B, A equals C. Logs, when you do this conversion, always go to exponents, and exponents, when you do this, always go to logs. I've seen a couple of times where logs become slogs and exponents become like exponents. Be careful about that. Once again, you will have a formula sheet for this class, for this test. So I do this. 6 to the 0 equals x squared plus 4x over 21. This becomes 1 equals x squared plus 4x over 21. You multiply both, and once again, it's algebra. So 21 equals x squared plus 4x. Subtract 21 on both sides. And you end up exactly what you had before, x squared plus 4x minus 21. Look at this quadratic. Over here, same quadratic. So this little trick of just getting rid of logs skips one step. Actually, it skips multiple steps, but it's the same exact style. So if you don't fully agree with this, if it does not make too much sense in your head, this conversion, you could just stick with what we've been doing before, and it works. Okay, one last quick one before I have to go. So looking at number 1, I know we did number 1 class, but I'll just say it again to have an example. So you have Fletcher, and he's depositing money. And we see he's depositing money compounded. Actually, do this. He plans to deposit money in an account. It's being compounded continuously. Once I see continuously, I should immediately be like, oh, it's A of t. It's immediately this. If you see how many times it's compounded, it's going to be compounded continuously. Continuously means E. And now I just label everything. What is A? I want to see the question is asking me how much money he would have. How much money he would have. We see how much money. That is either A or P. And P is my initial. A is my final. So A is what I need to find. So A is unknown. P, I see, we want to see how much he have in account after he deposits $1,000. So he's depositing 1,000. That's my principal value, 1,000. E is this E. That's not, even though it's a letter, it's not a variable. E is this E. R, my rate, is being 6% interest. So I have 6% or 0.06. And T is 5 years. With these type of problems, we're just labeling everything. Be like, I label everything that I know. And you should only have one question mark. That means that, like, depending on the problem, if it's asking you to find the exact value, in this case it is, yeah. We see later in number 2, we're like comparing values. Comparing values might have multiple missing. But I see A, I don't know. So A equals 1,000 times E, 0.06 times 5. 1,000 E 0.3. And you have A equals 1349.86. And for this stuff, I expect us to not need to know what to round to. For money, it's always 2 decimal places. And the very last question is part B of this. We want to see how long would it take in years and months to double his initial investment. I'll actually just do this. So how long would it take to double his initial investment? We want to, how long is time? And when you look at this problem, I said it before, only the parts in A are still relevant. unless it says in part A you found this, use it for part B. Part A, like question 1, what's written here applies to everything, and A only applies to A and B only applies to B. So T is unknown. We know rate is from the sentence above. We know it's continuous, so you have E. And A and P, we're not given values. But we see how long would it take to double his investment. So double means my final value is double my P. So I could do 2P, and this is P. Whatever my initial investment is, P, my account balance will be 2P. So 2P equals P E 0.06 T. Divide by P, because we want to get T by itself. And we slowly strip away the furthest and going in. So the furthest away is P. We're pretty sure the opposite of PEMDAS. If it looks like +4 over here, the +4 is furthest away. Then you do the multiplication. Then you do exponents. So divide by P, get 2 equals E 0.06 T. Now over here, we do B, A, C becomes ln of 2 equals 0.06 T. Divide by 0.06, divide by 0.06. And this 0.06 we're dividing applies to ln of 2, not just to 2, but the entire thing. So your final result is ln of 2 over 0.06 equals T. And that gives us 11.5524, or 11 years and 6.63 months. And let's take a quick look. Doesn't matter how much his initial deposit was. Let's look back at our work. If P was any value, A will always be 2P. A lot of us, I think we did it where P is 1,000 and A is 2,000s, and we divide it. You will always get 2 times that value over that value. So you always get 2. So think about it, we would not care if Fletcher's investment was $1 million or $2 million or like 10 million or even just $1 or 2 cents. It will always take 11 years and 6.63 months to double that investment. All right, I think I'm out of time. Thank you for watching. Good luck studying. If you have any questions, feel free to email me. Once again, the quiz is on Tuesday or Wednesday. Actually not. They're both on Wednesday. Yep. Good luck studying. Bye-bye.